So let's do an example of this kind of lattice energy trend type of question. So it says to place in order of increasing exothermicity of lattice energy. So which one of these has the most exothermic lattice energy? So remember, there's two things that you want to look for. There's charge and then there's size. And the one that plays a bigger factor is charge. So that's what you want to look at first. So think about the charges here. Calcium and oxide, those are plus minus 2, right? Calcium is plus 2, oxygen is minus 2. So that's the charge interaction there. Potassium and bromine, potassium bromide, that's plus minus 1. They're each 1. Same with calcium and chloride, plus minus 1. And then strontium oxide, that's a plus minus 2. So there's some clear differences, right? One set is plus minus 2. One set is plus minus 1. And remember, we said more charge, more exothermic. So we can say from that this potassium bromide slash this potassium chloride will have a less exothermic reaction than the calcium oxide and the strontium oxide, based on the more important factor, the charge. Now, to differentiate between the potassium bromide and potassium chloride, and then the calcium oxide and strontium oxide, we have to look at our next set of principle, and that's size. So remember your periodic trends. When we go towards this top right, we get small, and then over here we have big. So the differentiating factor here is whether it's a bromide or a chloride. So if we look at our periodic table, chloride's over here, bromide's under it. So Cl somewhere over here, bromide down here. And so chloride is smaller relative to bromide, and bromide is big relative to chloride. And then we do the same thing for this other side. The differentiating factor here is calcium versus strontium. So calcium here, strontium is underneath it. So if you think about the trends there, calcium is going to be the smaller one. While strontium is the big one. And so remember, we said small. If they're both small, then they're closer together. And closer together is more exothermic. So the small ones are going to have the more exothermic lattice energy. And so then we can put them in order: KBr, followed by KCl, followed by strontium oxide, followed by calcium oxide, in terms of more negative lattice energy. And so if you were to actually look up these values, you'd see that this trend would work out well here. So you can see it's the same order that we have, and you can see we get more and more negative of a lattice energy. And you can tell there's a big jump here relative to the other jumps, and that points out again that charge is more important than size. Cool.